This is Euclid Book 9, proposition number 19. See, we got 5 lines, A, B, C, D, and E, and each line is bigger than the one before it. Okay. Now, given 3 numbers to investigate when it is possible to find a fourth proportion to them. Let A, B, and C be the given 3 numbers, and let it be required to investigate when it is possible to find a fourth proportional to them. Now, either they are not in a continued proportion, and the extremes of them are prime to one another, or they are in a continued proportion, and the extremes of them are not prime to one another, or they are not in a continued proportion, nor are the extremes of them prime to one another, or they are in continued proportion and the extremes of them are prime to one another. Wow. Okay. If then A, B, and C are in a continued proportion, now remember this would be as A is to B, so as B is to C. That's a continued proportion. If then A, B, and C are in a continued proportion and the extremes of them, A and C, are prime to one another, remember, they're not prime numbers, they're just prime to one another. Okay? It has been proved that it is impossible to find a fourth proportional number to them. And this is by Euclid Book 9, proposition number 17. Next, let A, B, and C not be in a continued proportion, the extremes of them being again prime to one another. So now it's not as A is to B, so as B is to C. We could probably say as A is to B, now C is to D, something like that, okay? And remember that whenever you're talking about the extremes, you're talking about A and this hypothetical D, and those numbers at this point are going to be prime to one another. Not necessarily that they're going to be prime numbers, they're just going to be prime to one another. Big difference. I say that in this case it is also impossible to find a fourth proportional to them. For if possible, let D have been found so that as A is to B, so as C is to D. As A is to B, so as C is to D. That's what we're talking about here. Okay. And let it be contrived that as B is to C, so as D is to E. As B is to C, so as D is to E. Okay. Now, since as A is to B, so as C is to D, and B is to C, so as D is to E, which I just told you a minute ago, therefore xi quali as A is to C, so as C is to E, and this is by Euclid Book 7, proposition number 14. Now hold it. As A is to C, so as C is to E. That's what they're saying. That's the xi quali right there. But A and C are prime. Primes are also least, which is Euclid Book 7, proposition number 21. And the least numbers measure those which has the same ratio, the antecedent to the antecedent, and the consequent to the consequent, which is Euclid Book 7, proposition number 20. Therefore, A measures C as antecedent. But it also measures itself. Therefore, A measures A, and A measures C, which are prime to one another, which of course is impossible. So now what they're saying is that if you did all the things that we said you were supposed to do, then A would not only measure itself, but it would also measure C, which of course is impossible. So there you go. Therefore, it is not possible to find a fourth proportional to A, B, and C. Next, let A, B, and C be again a continued proportion. As A is to B, so as B is to C. That's a continued proportion. But let A and C not be prime to one another. In other words, let's say A is 2 and C is 4. Okay? And they are both measured by 2. That means they're not prime to one another. I say that it is possible to find a fourth proportional to them. For let B, by multiplying C, make D. Okay? B times C will make D. That's what they're saying. Therefore, A either measures D or it does not measure it. First, let it measure according to E. So A is going to measure D by the units in E. A measures D by the units in E. That's what it's saying now. Okay. Therefore, A, by multiplying E, has made D. A times E. Let me say that again. A times E makes D. But further, B has also, by multiplying C, made D. So B times C makes D. Therefore, the product of A and E, so you take A and multiply it by E, and that result is going to be equal to the product of B and C. In other words, you're going to take B and you're going to take... Let me say it this way. If you take A times E, you get a product. If you take B times C, you're going to get a product. Well, the product of A and E and the product of B and C is going to be exactly the same. That's what he's trying to say. Okay. Let's go on here. Therefore, proportionally, as A is to B, so as C is to E, and that's by Euclid Book 7, proposition number 19. As A is to B, now C is to E. That's what they're saying. Okay. Therefore, E has been found a fourth proportional to A, B, and C. Next, let A not measure D. Okay, this time A will not measure D. I say it is impossible to find a fourth proportional number to A, B, and C, for if possible, let E have been found. Therefore, the product of A and E is equal to the product of B and C. So A times E, that product is going to be equal to B times C. This is by Euclid Book 7, proposition number 19. But the product of B and C is D. Now, let me show you this. First we said A times E equals the product of B times C. Now we're saying that the product of B and C is D. So B times C equals D. Now that's what we're going to say. Okay. Therefore, the product of A and E is also equal to D. So if we take A and we multiply it by E, we get D. Therefore, A, by multiplying E, has made D, which that's what we said. Therefore, A measures D according to the units in E. So, A measures D according to the units in E. That's what it's saying. Okay? So that A measures D, but it also does not measure D, which is absurd. It either measures D or it doesn't, one of the two. Therefore, it is not possible to find a fourth proportional number to A, B, and C when A does not measure D. Next, let A, B, and C not be in a continued proportion, nor the extremes prime to one another. And let B, by multiplying C, makes D. Okay? So A, B, and C are now not in a continued proportion, as in, as A is to B, so as B is to C. It's not like that. Okay? And the extremes of them are not prime to one another. Okay? And let B by multiplying C makes D. So now, B times C makes D. Okay. Similarly, then, it can be proved that if A measures D, it is possible to find a fourth proportional to them, but if it doesn't measure it, it's impossible. Whew. What a long proof. Alright, if you want to go through with the rest of that proof, you go right ahead. Euclid doesn't. We won't either. Alright, I will tell you more in my next video, so stay tuned.